I'm Stephen Rigler. I'm an HPC cloud engineer at Chevron. This is Blake Ray.
Also a cloud engineer.
Also
at
a cloud
Chevron.
engineer. And this is organizing, optimizing VDI solutions for geophysical workflows in subsurface exploration. Basically, we're talking about our VDI solution in the cloud and how we got to it. So we're probably going to start pretty early in the history of our remote visualization. So we're going to be starting pretty far back, and we're going to work our way up to cloud, so you can kind of understand the challenges we went through along the way. So why remote visualization? So back in the day, our workstation solution was actual physical workstations located in everyone's office. So there was a 1-to-1 ratio of users to workstations. The workstations were physically located in the users' offices underneath their desk. There wasn't a whole lot of standards as far as how users would use them. Some people would have 2 sets of monitors, some people would have 1 set and switch between the 2 machines with a KVM. I'm talking about their office PC and the workstation. Some people would remote into their workstation from their PC. Some people would actually do the reverse, where they would work on their Linux machine and then RDP into their Windows desktop. So there wasn't a whole lot of standards. There's also, inherent with having machines in offices, there's a lot of support overhead. So, there's the necessity to visit machines whenever they have problems. So, best case scenario, the machine you need to visit's in the same building and it's not behind a locked door. So, we'd have cases where we need to visit a machine in the next building, and, granted it's not 4 miles through the snow to get to it, but it's still in the next building, and it's a lot of overhead to go back and forth to visit them. So eventually we standardized on workstation blades in the data center. So we started removing the desktops, deploying workstation blades to the data center. So that's obviously where the remote visualization becomes necessary. So at that point, we standardized an RGS, which is good for the users because then they can work on their office PC, their remote session would be visible in a RGS window, and then they can work on both their PC apps and their their Linux apps at the same time. So there's relatively easy workflow. So then moving the workloads into the data center that let us get rid of the 1-to-1 ratio of users to machines. So every workflow is different. You have some users that use their workstation 90% of the time, then you have some users that might only log in once a month. So with desktop PCs in their offices, if you use it at all, you're going to get a workstation in your office. Moving these into the data center allowed us to reduce the number of machines. So users that don't use it that frequently, they don't necessarily need a dedicated machine. But to simplify access, we needed a broker solution. So users could identify machines to log into. At the time, we opted to use an in-house solution. It was entirely written in-house, and it would essentially we could organize the workstations into pools. So they would either they would be a pool of machines that belong to a particular business unit, or organized by location, or by physical attributes like the amount of memory, graphics card on them, that type of thing. So this simplified things a lot for the users, and we used that for the better part of a decade up until we started to move towards cloud. So up until this point, it's kind of one of the important things to know about the challenges is that this wasn't a big bang change. We didn't just suddenly get rid of desktops and then users showed up on Monday and they were hitting blades in the data center. It was all incremental, and it wasn't all types of machines at one time. So some business units would prioritize purchasing new equipment, other ones would prioritize later on. So we had a mix of types of hardware. So I think probably before we started moving to cloud, we were supporting 4 or 5 generations of graphics cards. So it's quite a bit of overhead to that. So once we started moving to cloud, we just did a basic lift and shift. And so the benefits were, pretty obvious right away. It's like, instead of having people on 5-year-old graphics cards or 2-year-old graphics cards, all of a sudden everybody had access to the latest hardware. And resizing was fairly trivial. So we could set up pools of like small, medium, or large machines, and depending on demand, we can resize them so users could have access to whatever they needed just based on demand. And again, just based on the nature of cloud, there's other challenges also, but that was the obvious benefit right away, is that they had access to the latest hardware that can do the work they needed right away. So which brings us to overcoming the other challenges of cloud. So there's kind of the elephant in the room is you don't want to leave a bunch of idle machines just burning money. So we needed a solution to optimize the cost from that perspective, and at the same time kind of help manage the user behaviors a little bit, because inherent with having machines on-prem, users could park on a machine for as long as they want, and it was handy for them because it was always there for them when they wanted to get to it. But from that behavior doesn't really translate to cloud. So we started looking for a vendor solution to replace our in-house broker and optimize some of that.
Yeah, so as we began moving into the cloud, the resource benefits were obvious with getting the latest hardware, but overcoming the challenge of cost with all these machines wasn't an immediate thing that we had sorted. As we were moving into the cloud, we were basically lifting and shifting machines from on-prem into cloud, and they were running 24/7. Obviously, as we began to do that more, that wasn't going to be cost efficient. So our internally developed broker software was never really designed to handle anything like that. So our options were basically overhaul our internal broker and keep maintaining it to try to implement some of the user access challenges that we were trying to take care of, and add some sort of mechanism for the cloud scaling. We didn't want to keep maintaining that, and we wanted to reduce some of our technical debt of maintaining an internally developed program. So what we wanted to get done was move to a vendor-supported solution that could already handle all of this for us and address not just the cost efficiency problem, but also some of the user access. And so I will move into how we did that. Getting into our hybrid environment, there's two main pieces to this, the desktop broker and then the visualization client that the users actually use to view the desktops. The broker that we chose to use was LeoStream because it could handle a lot of this for us, and I'll talk through the main components that we use in our environment. So the concept of centers down at the bottom of the slide are basically sources for desktops, and those can be physical, vCenter, or any of the cloud providers, but it already has all the built-in functionality for handling that. So that got us right off the bat the ability to manage all of our desktops around the world in one place and not have to keep updating configurations that were used in our internal broker. And then once you have the centers defined, you can make pools based on resource type or fit for purpose, kind of like how we were doing it previously. But the interesting part of using LeoStream is that we were no longer presenting every desktop we had in the world available to every user, and they had to go wade through it. We can now assign specific desktops to people and control how they, basically how they were presented. So they get, and that's where policies come in, assignment policies. And with those policies, you can define actions called plans for how the desktops are connected. The main ones that we use are power control, which basically determines if this is an Azure machine, can we shut it down? What options do we want to give the user? Do we want them to be able to start and stop their own desktops or reboot them? And then also idle release was a big one for managing the power states efficiently. So we could say, okay, in this pool of machines, keep one running all the time so that whenever somebody connects, there's always one ready. But the rest of them can all be shut down. And then for the broker or the visualization client piece of this, we chose to move off of RDS because we wanted to do something with better performance, and we chose Mech9 TGX because it's a good high-performance visualization tool and can support multiple monitors over fairly low bandwidth connections, more so than RGS could at the time. But one of the main reasons that we chose it was because it can pair well with LeoStream in doing pass-through authentication. So basically, a user can log into LeoStream, they get presented all of their desktops, and every time they connect to one, they just get dropped straight in. There's no secondary sign-in or anything like that. So that accomplished our user access and enabled us to leverage some of the cost benefits of the cloud. This was a big change from how we were doing things. All these resources weren't online 24/7. So we had some key points that we wanted to address to make sure that we had a smooth transition for our users. Number one being the reduction in idle machines. Some users liked to use several machines at once, and they would leave them running, something running on them 24/7 and be logged into 4 or 5 at once. We reviewed some of those cases and found that some of the things that they were doing weren't necessarily suited to be on a workstation. We migrated some of those workflows onto the cluster nodes where it made more sense, and we're able to get performance improvements there. Additionally, with machines being assigned now, we wanted to make sure that users were getting the right resources, and basically trying to understand some of those cases where they had multiple machines. And some of them do have legitimate uses for it. They are running multiple graphical workflows at once, and we created pools for allowing users to do that where they can get between 3 and 6 machines or whatever they need. So we were able to address it on a case-by-case basis instead of having people occupying a fixed pool of resources and then starving out other users. Idle release was another big one that we had to do carefully. People don't want to be logged off of their machines. But on the flip side of that, we want to be efficient with how we're using our resources. So to do that, we created a couple of pools, or a couple of plans, 2-day, 5-day, and 7-day. So for certain groups of users, they got a 7-day release where their machine could be idle for 7 days. They could work throughout the weekend. But if they are kind of you could call it bursty user, where they might use it for a while and then not use it again for a month, we were able to get some cost efficiency there. And then other groups, we turned it down basically to optimize the resource efficiency. And then finally, one of the challenges was custom resolutions. We have several, you can call them power users, that have very customized work environments with multiple monitors. And then they also had, they wanted custom behaviors on how the desktop's displayed over their local machine. Some users like to have a Linux desktop and then have a Windows taskbar that's presented underneath. And we came up with workarounds for them on how we could present that way with how we're connecting to the machines. And then we also worked with the vendor to add that functionality for future releases. Oops. And what we got out of that were these 4 points here. Big one being power control, that we can now efficiently leverage cloud resources and be able to deliver results for less cost. And it also enabled, as admins, it reduced some of the overhead with maintaining these machines. These high power workflows, they often run machines out of memory or get them into undefined states. And the process for that before used to be, you'd have to put in a ticket and have an admin take care of it. Now, with a lot of these people working through weekends too, they can do it themselves and save a lot of time. User access management was a big benefit for us, mostly to get rid or mitigate some of those behaviors where people were occupying several machines at once. Now they get the resources that they need, and they're presented the relevant resources. And then inventory management became a lot simpler for us as admins and for the users, because we no longer had to go through manually editing files and maintaining this growing and shrinking inventory. We have something that would automatically add and remove desktops as we created them and add them to the appropriate location for any site or on-prem or in Azure. And then finally, most importantly, the user experience. They don't have to maintain this locally installed app on their desktop. They just go to a website and then they get the relevant resources presented to them. Again, they can reboot machines at their leisure. And finally, they have resources always available. They're not being starved out by other users. And that was how we optimized our virtual desktop infrastructure. We'll take your questions now.
Thank you. Hello. So you said you have instances running in the cloud and then you have instances running on-prem. How do you deal with storage, POSIX versus object store, and low latency access?
Good question. So our primary compute clusters are in Azure, and so are our high-performance storage system, so parallel file system and NFS. Most of the resources are co-located. So say for North America users, most of their workstations are in Azure and co-located with all those resources. For on-prem users that have on-prem clusters still, their resources are still on-prem. And we're still migrating most of the other sites, but most of North America runs in the cloud.
Yeah, so basically the data is all co-located with the machines, and we present the machines based on group membership. So if you're in a group relevant to a particular region, you're going to be presented machines from that region. So you log into them, you're going to get the data that's close to them. No, I mean this isn't really pertaining to object store in any way. It's
The storage systems are still presented to the desktops as NFS or POSIX
legacy
compliant.
NFS or CIFS or whatever.
All right, any other questions?
Thank you. Great presentation. What about economics? Investment, moving physical workstations to the cloud. Is that a big return, savings, extra costs? I know cloud charges for every mouse move you do. So is it going to improve, equal, or expense?
I don't know if we can really compare cloud to on-prem.
There's a lot of factors packed into that we probably can't answer here. But as far as the economics of moving them, at least what we've done so far, I'd say it's on par or more effective than doing another expensive hardware refresh for all of this infrastructure with the desktops. And it's not only the desktop infrastructure. If we wanted to do on-prem virtual desktops, we'd have to have cluster and storage all on-prem as well. So that's probably as far as I can answer that.
Yeah, I mean the main benefit for this is that we could, we only had the stuff that you needed powered up. So, if you're using it, you're paying for it. When you're not using it, it's shut down and, it's not burning money.
All right, we got time for one more. If there's any others, if not, wait, here we go.
Do you have any utilization metrics that you're tracking? So for example, do you know when you have to grow your number of resources because you have utilization at 80, 90% across everything, or?
We do track that. Currently, we have a deployed footprint that's well within the capacity, but we do monitor the utilization of, okay, we have this percentage of machines that are allocated, and of those allocated machines, we have this percent that are sitting idle. So we can manage how effectively we're using it.
All right, Steve, Blake, thank you very much.